All right, hello. My name is Evan Espinosa, and if you'd like to introduce yourself.
Yeah, my name is Utkarsh Byahut, and we are group number 44. We don't have to go for members here, but we are four people, and our group is called Perpetual Motion Squad. We are presenting our project today, it consists of three parts: application requirements, the ERD diagram, and the database schema. So yeah, let's just go over it. Even take over.
Yep, let's get right into it. Let's start with part one, the application requirements. So today we are presenting our project for the ASU Research Participant Registry and Scheduling System. Now, the purpose of this application is to replace the current patchwork of spreadsheets, emails, and paper forms used across labs at ASU with one centralized compliance system. This web app makes it easier for participants, researchers, and administrators to manage recruitment, consent, scheduling, and payments. So we have three main user roles. First, participants. Participants create a profile, verify their contact information, and browse active studies that they are eligible for. They sign consent forms, enroll in sessions, and track their payments. Second, researchers. Create and manage studies, publish sessions with dates, rooms, and capacity, and oversee enrollments, attendance, and payments. And finally, third, administrators, such as the IRB staff or department coordinators that oversee all studies, manage researcher accounts, ensure compliance, and run payment and audit reports. Now, the core functionality of the system includes a participant registry with profile and eligibility tracking, a searchable study catalog with filters like compensation type, GPA, or campus, consent management with version control and withdrawal tracking, scheduling that prevents double bookings for both rooms and participants, enrollment and waitlist handling with automatic promotion when seats open, payments issued only after attendance is confirmed, and compliance and audit logging, ensuring the system meets ethical and institutional requirements. In short, this application ensures research at ASU is streamlined, compliant, and participant friendly. Now, the second part that we'll cover is the ER diagram. So, this will show how our database models the system. At the center, we have the participant entity, which stores details like name, email, GPA, and demographics. Participants can enroll in many sessions, and this relationship is captured in the enrollment entity. Each enrollment has a status, enrolled, attended, waitlisted, or canceled, and also connects to payments, since only attended enrollments generate a payment record. Next, the study entity holds information like title, description, and eligibility requirements, such as minimum GPA or age. Every study has one or more consent versions, which track versioned consent documents with effective dates. Participants sign these through participant consent, creating a full audit trail of those who signed which version and when. And finally, each study is linked to study researchers, which records the researchers involved along with a role such as PI or coordinator. And for this next part, I want to hand it over to my friend Utkarsh.
Awesome. So, continuing with the ER diagram, we also have room and session entities that you can look at over here. Yeah. So the room and session entities, which essentially belongs to one study and one room. A session can only happen in one study and one room. The room has a capacity and exclusion constraints preventing overlapping sessions from being scheduled in the same room. The session entity also connects directly with enrollment, where we enforce participant eligibility, consent checks, and cooldown rules. Importantly, a participant cannot double book themselves across overlapping sessions. The diagram also shows payment, which is tied to an enrollment. Payments record the method such as cash or gift card and their status from pending to paid. In summary, the ER diagram shows a normalized schema with clear relationships between participants, studies, sessions, consents, enrollments, and payments, and the relationships between them. This structure supports all of our business rules while remaining efficient and auditable. Now, coming to the implementation plan. Let's take a look. So our implementation plan essentially is using like a lightweight REST API and Flask, which will be like, composed of a three-tier web application. At the bottom, we use PostgreSQL as the database. PostgreSQL is ideal because it supports advanced relational features that we need. such as exclusion constraints for scheduling conflicts, recursive CTEs for enforcing cooldown rules, and materialized views for fast reporting. The middle layer is a Flask backend in Python. Flask allows us to build lightweight but secure REST APIs, handling endpoints for study research, enrollment, consent signing, and payment tracking. Business rules like eligibility checks or ensuring the correct consent version is enforced in this layer. On the front end, we'll use a simple HTML, CSS, and JavaScript dashboard. Participants can browse studies, sign consents, and enroll in sessions, while researchers and admins can view reports and manage utilization. For data visualization, we integrate chart.js or Plotly to show trends like attendance or payment distribution. For deployment, we'll be hosting the backend and frontend on platforms such as Render or Railway, connecting securely to PostgreSQL, manage our code and version control through GitHub. This plan ensures we deliver a functional, compliant, and scalable prototype for ASU's research community. Now, this is a little like beyond, but we are also following uh, a sprint based tracking mechanism here, which we haven't mentioned on the document here, but we'll leave a link to because it was like very big. It's a week by week breakdown of what we'll be essentially doing, and this is the codex that we work out of. If you see, we are already done with the week one sprint, and we are currently at the week two sprint. Currently we are developing the database for the project, which is going to be a dummy data set which we'll create using a script. And then, yeah, there's week three, week four, and all of the others supposed to be completed in the eighth week of our project. This is our project. This is the proposal phase one document that we are sharing today. This is the ERD diagram, which is also attached in the assignment. And this is our gospel document, which we'll be following for completing our sprints. And essentially, that is it. Thank you so much for looking at our project, and we hope to deliver a good one soon. Okay, bye bye. Awesome.
All right.
Stop recording.